The first concept, electric charge. On the basis of the electric charge concept, NEET and mains MCQ questions, the multiple choice questions, very important questions are there. Let's discussion one by one. Start with the electric charge, first one. If the soap bubble is given a negative charge, you know very well, this is the soap bubble. So in this soap bubble, given the negative charge, then radius, question mark. So when the negative charge is given to the soap bubble, on the surface of the both the sides, it is a negative, negative, negative. So because of the like charges, this is a repulsive force on the surfaces. The surface is extend their surface. So because of due to the like charges, its radius is also increases. So let's see, initially radius is small r. So after the negative charge is given to the soap bubble, radius is capital R. So which is greater? The capital R is greater than to the small r. The radius is increases. That is option B is the correct answer. Question number 2. When a body is earth connected, so this is the body. The body is connected to the earth. Connected to the earth. Earth means sharing of electrons. Electrons from the earth flow into the body. From the earth to the body. So this direction electrons are flow. So does the body becomes positive charge, negative charge, insulator or uncharged? So let's take one by one. First one, if the body is negative charge. So this body is negative charge. So when the negative charge, if the body is negative charge means, so these excess of electrons are flows towards the ground. But the question is not like that. The electrons are flow from earth to the ground. So that means the body is not negative charge. So this is the fail. Okay. Second, take the same body. Okay. If the body is positive charge, if the body is positive charge, okay, so the body is positive charge means, so these electrons are, okay, from the ground to the body moves along this path. Why? Because of unlike charges. This is positive, these are the negative charges. The unlike charges are attracted. The reason the electrons are flow from earth to the body. So that is option B is the correct answer. Insulator, uncharged body means the electrons are does not flow from ground to the body. So insulator means in the insulator it is a no charges is flow. So next question. Energy associated with the moving charge due to. So let's take, this is the charge. So when the charge is at rest condition, it produces only electric field. This is the first thing. So if the charge is moving with the constant velocity, So then it produces both electric field and magnetic field. So that means a moving charge. So this is the moving charge. It produces both electric field and magnetic field. Okay, so that means that is a option C is the correct answer. Fourth question. When a charge is given to the conductor. Okay, so this is the conductor. Okay, let's take the conductor. This is the conductor. When the charges is given to the conductor. So this is a regular body. So in this regular body, the charges are distributed uniformly throughout the surface of the conductor. You know, according to the properties, the charges is resides only the outer surface of conductor. This is the surface phenomena. Those charges are distributed uniformly throughout the surface. So let's take the irregular body. If the body shape is irregular like that. So in this condition, the most of the charges, okay, this is the less curvature. In the less curvature, the more number of charges are accumulated on the less curvature. The curvature is more, the less number of electrons are accumulated on the surface of conductor. Okay, so that means this is the two important points, the surface phenomena. More charges accumulated at the region of small curvature. More charges are accumulated in the region of large curvature. So more charges are accumulated in small curvature. So this is the option A is the correct answer. So the less charges are accumulated. Less charges accumulated in the region of large curvature. Charge distributed uniformly irrespective to the curvature. Yes, it is a not for irrespective, it is a respective to the curvature. So these two are wrong answer. That is a option B is the correct answer. Next one, fifth question. How many electrons should be removed from the coin of mass 1.6 gram so that it may float in the electric field intensity this much? So this is the electric field. This is the electric field. Electric field is starting from positive and terminated with the negative side. So this is the coin is floated on this one. So this coin is so how much it is? 16 gram. 1.6, not for 16, it is a 1.6 gram. That is equal to electric field is this much. So how many electrons are removed? How many electrons are removed means n is question mark. So in this problem, the charge is not given. You know the formula Q is equal to N into E. Then N is equal to Q by E. So how to find out the Q? So this charge is float in the electric field. The downward force is equal to how much? Mg. The upward force, because of due to the electric field, how much force is exerted in upward? So let's see the equation. E is equal to F by Q. Then F is equal to what? E into Q. So both these two forces are opposite direction. So that is the reason E into Q is equal to mg. But Q is not there. So Q is equal to N into E. Put instead of Q, you put Ne. E into Ne is equal to mg. I want to number of electrons. So N is equal to mg divided by E into small e. N is equal to m is 1.6 gram, convert into kg, 1.6 into 10 to the power of minus 3. G is 10 divided by E is electric field is 10 to the power of 9 into E. Elementary charge value is 1.6 into 10 to the power of minus 9. So now simplified, I cannot drag the simplified. So just to put the simplification, the answer for the, so this one is how much? It is 10 to the power of 8. So because 10, 1.6, 1.6 get cancelled. So 10 to the power of minus 10 shifted. So it is 10 to the power of minus 2. So it is 8. That is option C is the correct answer. Sixth one. A body is charged by rubbing its weight. Okay, I said already in the theory part. So when the two bodies, for example, this is the body A, that is the another one body is B body. So the one body is losing the electrons. Okay, so the one body is losing the electron. One body is losing the electrons. Another body is gain the electron. Okay, so you know electron, mass of the electron. So one electron gain means the mass of electron is equal to 9.1 into 10 to the power of minus 31. So one electron gain means this becomes mass is added. 2 becomes into 2. So gaining the electron becomes mass is what? Weight is increases because weight is equal to m into g. So weight is increases. So losing the means weight is decreases. So a body is charged. Both the bodies are charged. So by the rubbing method, the one body is charged by the gaining the electrons. Another body is charged by losing the electron. So that becomes always increases slightly, maybe increases slightly or maybe decreases slightly. So it maybe increases or decreases. So both it is a happened. So that is a option B is the correct answer. Okay, so many students have lot of confusions. A body is charged by rubbing means its weight maybe increases or decreases. So both the cases it is happening. Okay, but one of the body is gain the electron, the one of the body is lose the electrons. What is the amount of charge possessed by 1 kg of electron? Mass of electron is this much. So what is the amount of charge possessed? So mass is equal to 1 kg. So give the mass of electron is this much. Okay, so how to calculate? First, you have to calculate the n value. Okay, so n value means number of free electrons. So how to calculate the number of free electrons? The number of free electrons is equal to, okay, so number of free electrons is equal to m mass divided by mass of electron. This is mass is 1 kg. Okay, so charged possessed by 1 kg, that is equal to 1 divided by mass of electron is 9.1 into 10 to the power of minus 31. So that is a n value is equal to 1.1 into 10 to the power of 30. So charge, the formula for charge is Q is equal to N into E. So N value is 1.1 into 10 to the power of 30 into E value is 1.6 into 10 to the power of minus 19. That is the answer is equal to minus 19 plus 30 and it is a plus 11. So plus 11. So 11 into 6, 66. 11 into 1, 11 plus 6, 17. So 2 point, that is a 1.76 into 10 to the power of 11 coulomb. So that is a option A is the correct answer. Next one, question number 8. An uncharged metal object M is insulated from its surroundings. This is a uncharged metal object. M is insulated from its surroundings. A positively charged metal sphere S is then brought near to the M. So uncharged body means, so this is the uncharged body. Okay, so this is the uncharged body. Another one, it is a positively charged body. So uncharged body means number of protons is equal to number of electrons. So now this body is M. This body is S. It is positive charge. Okay, positive charge. Positive charge. So when this body is brought near to the M, one by one by step, so then, so this M positive repulse you. So because of due to the like charges, positive repulsive. So because of due to the repulsive, the positive charges, okay, the positive charges this side. So in this side only negative charges. So this side is positive charges. So in this metal sphere, okay, so in this metal sphere, so this side is positive charges. This side only because positive are more positive charges. So that becomes, so which is the figure is familiar with this one? S is positive, M is negative, but M is a uncharged. So M is a uncharged means this is negative, this is a figure is wrong, this is also wrong, this is also wrong. It is a M is a neutral. Let's see, 1, 2, 3, 4, 3, 4. Same uncharged body. So this side is negative, this side is positive. So that is the figure D is the correct answer. Okay, next question is question number 9. Assume that each copper atom one free electron. So each copper atom, so each copper atom is equal to one free electron. One free electron. So then estimate the number of free electrons in 1 mg of copper. So how much electrons are there? You have to calculate. Number of free electrons in 1 mg. Given atomic weight of copper is this much, Avogadro number is this much. What is the charge possessed by these free electrons? You have to calculate the charge. So charge is equal to N into E. First you have to calculate N. So how to calculate the N? So N is calculated by how many atoms. Each atom is equal to one free electron means, so number of atoms in 63.5 gram of copper. So because free electron, atoms is equal to free electron means this is N. That is equal to, so Avogadro number, because Avogadro number means, so in 1 gram nalli, that is equal to how many molecules are there? That is Avogadro number divided by M. So that is equal to 6.02 into 10 to the power of 23 divided by 63.5. It is a gram. So now estimate the number of free electron in 1 mg. You have to calculate 1 mg. 1 mg. This is a N is equal to. So calculate that. So the answer for this one N is equal to 0.0948 into 10 to the power of 23. So number of free electrons. Number of free electrons in 1 mg is equal to 0.0948 into 10 to the power of 23 into 1. It is milligram, convert into gram, 10 to the power of minus 3. That is equal to 9.48 into 10 to the power of 80. Okay, so I got N value. By using the N value, you have to calculate the charge. So you know very well formula, charge Q is equal to NE. Then charge Q is equal to N value is 9.48 into 10 to the power of 18 into E value is 1.6 into 10 to the power of minus 19. The charge Q is equal to 1.517 coulomb. Okay, so dear students, I cannot drag the simplification because it's water. Take more time to show the simplification, but this simplification is not complicated. It is very simply steps. So the value of the Q is equal to 1.517. So that is the answer is 762546. That is the option, approximately equivalent to the option B. So the option B is the correct answer.